Okay, this is the third to last week of class. I'm almost finished with grading the writing assignment 3. I'm hoping to get that done this afternoon. Next week we have scheduled kind of a, uh, a catch-up day as well as an exam day scheduled. I'm planning to make the exam a take-home, something like a week-long thing where I'll post the questions sometime mid next week, and then you'll have a week to make your responses to those and upload them to Canvas. What I might end up doing in that case is we could maybe use part of next Tuesday's class and next Thursday's class for group Zoom meetings. And then then the following week, the last week of class is presentations. And I was imagining, in my head when I was writing those down on a syllabus, in my mind I was imagining those being in person. It seems like we're going to have to be doing those over Zoom, and so I apologize for that. And I think we'll just have to make the best of that. I'll schedule a couple of those on Tuesday of the last week of class, and then a couple of those on Thursday of the last week of class. And then you guys can find out what it's like to talk to a screen with people just kind of in their own houses, maybe watching or maybe not watching. So that's the last week. That'll be the sort of the last thing we do together. So that's coming up. That'll be in 2 weeks from now. So this is what we had introduced a little bit last class, and I want to. We talked a little bit about the rationale and the justification for coming up with distributional weights, and just hinted at a little bit of a method for maybe one way of coming up with weights. I'm going to just go over that again, and then there's at least one other method, which is kind of actually a revealed preference method, where we can actually look at what policies are actually implemented by society. Consider what an unweighted benefit cost analysis looks like for those. We might notice that an unweighted benefit cost analysis might come out with a negative NPV, but nevertheless, certain policies might be enacted just as a result of social values about different distributional outcomes being desirable. And one of the ways we can actually determine what the revealed preference for distributional weights are is to take policies that actually are implemented, consider those relative to the unweighted cost benefit analysis, or what a set of alternatives might be, and we can actually sort of back out what the implicit weights were that were used in the process of making that policy decision. If we observe that something had a smaller NPV or a negative NPV, and yet nevertheless it was chosen, one of the reasons it could have been chosen was for distributional or equity reasons, and you can essentially solve for a set of weights that makes that NPV positive, or would make a certain alternative superior to a different alternative, even though the unweighted cost benefit analysis might be less desirable or less preferable from an unweighted perspective than something else that maybe would have higher net benefits overall. And I'll explain kind of how that works, and I'll go through an example of that. But I think it's kind of an interesting way to approach the problem, because these are value. At the end of the day, these are value judgments, and so inevitably you're going to have to be, if you are assigning distributional weights to help bring in distributional concerns into your analysis, the question is, what weights do you use? And you could maybe take past policies that have been enacted by the EPA or other government bureaus, and actually see, like, maybe what weights have they applied in the past, and maybe even using uh, this technique I'm going to show you to kind of back out what the implicit weights were that were applied, given that an unweighted cost benefit analysis would recommend something different, and yet this um, other policy was chosen based on presumably some preferences, social preferences for certain distributional outcomes. I have a graph here just to kind of set things up and kind of remind us where we've been. This is a graph that shows an example of some kind of tax and transfer program. So we've seen some of these supply and demand graphs before. This is these upward sloping lines are the supply curve for some good. The downward sloping lines are the demand curve. You might think about some policy that's enacted in society, which taxes certain kinds of goods, and then collects those taxes and then transfers those goods to another party or another segment of the population. Maybe it's targeted just to a certain income level, or maybe it's targeted to a certain region, or maybe there's other defining characteristics that are the object of the policy. But we can just think of this as some general tax and transfer program where there's some good with some original supply curve. There's some tax applied to that, so that's going to, according to this this yellow line being sort of representing the upward shift in the supply curve as a result of the tax, where each suppliers are now not just forced to pay their labor costs and their materials costs and their land costs, but now they have an extra cost where they're sending money out of their revenues to Washington D.C. or to Harrisburg, depending on whether it's a state or federal tax. That's going to influence the prices that people face. So this price PC is intended to indicate the price that consumers face as a result of this tax. So the price that consumers face is a little bit higher than it otherwise would be. The price that this is indicating the producer price, that's PP. For that lower level price, that's the price that producers would actually receive net of the taxes that they're sending to the government. So there's a wedge, there's a gap between what consumers pay and what producers receive. We talked about how this is going to have an effect of changing the quantity of production. So this is a restriction in quantity implicitly because the tax is artificially increasing the prices of these goods. There's less transactions that occur. There's less quantity sold, and so there's different changes in welfare to different parties. So the consumers, if the price in the initial world was, I'm just going to call this P0. This was the price in the initial world. The consumers, in the process of experiencing these higher prices, are losing consumer surplus. That's going to be this A plus B. Consumers are losing some surplus, where they're paying higher prices than they otherwise would, and that's going to force them to give up more of their income, as well as force them to actually restrict some of their purchasing. They're going to be paying more for what they buy, but they're also going to be buying less, and so their consumer surplus falls by this amount, A plus B. Producers similarly are selling less than they otherwise would in an undisturbed market, and they're also receiving less than they otherwise would because now some of their costs involve tax payments to the government. And so the producers are losing some amount, C plus D. So that's a loss in producer surplus. This is a a consumer surplus loss. And then presumably uh, there's some transfer of this money. So these funds, remember the funds that are collected here, I can actually draw a box around that. So the basically, A plus C is the tax revenue that's collected. So it's the amount of the tax. That's the vertical height of that rectangle. The amount of the tax times the quantity that's sold under the tax. So QT, we can think about QT being the quantity that's sold under the tax. So that rectangle represents the tax revenue collected. Under a tax and transfer program, this tax is enacted. Producers and consumers in this particular market, they lose a little bit of their surplus relative to what they had before. But then this money can be collected by the government and actually used towards some project or even just an income transfer, maybe to some group that it's desirable from a social perspective to help them out. So this is just the basic structure of a tax and transfer program, basic economic analysis of this. We can consider what this looks like in a benefit cost table. So here we have a benefit column and a cost column. The costs, as I mentioned on the last slide, we have A plus B representing the loss to consumers, C plus D representing the loss to producers. And then those who benefit from, presuming that this tax revenue is collected and then used to transfer to other folks in society, those people in society actually gain, just under the assumption that all of this tax revenue is then transferred to another group. Those people gain A plus C. And so from a social perspective, if we tally all these things up, the A and C that represent benefits to transfer recipients, those get canceled out with A plus C that represents costs to either consumers or producers in this goods market. And then what's left over after you net that out is B plus D. That's just the common deadweight loss triangle that we see in most kinds of tax analysis, where the transactions that are not occurring because of this tax, those represent transactions that would be mutually beneficial for both consumers and producers, but because the tax drives a wedge between the price that consumers pay and the price that producers receive, there's actually less of that activity going on, and so there's a overall loss to society of B plus D. That would be I'm going to call this unweighted benefit cost analysis of this transfer program, where you're not adjusting any of the numbers based on who the people are. You're treating everybody as consumer or producer surplus or income change. You're treating all of that as being the same. Now let's consider the case where you might weight benefits or costs in different ways. So I'm going to call this the weighted CBA. And this is, again, referring to the simple tax and transfer program that was illustrated with that supply and demand graph, where there was a tax on that good, and then the tax revenue was used to transfer it to some other folks. The general structure of this, or at least one specific way to think about this, one very simple way of thinking about this, is that there are these deadweight losses, right? This is the B plus D. That's what we saw that was lost from a social perspective, based on the transactions that weren't occurring from the tax, due to the tax interference. Those were the social costs under under the unweighted version, that was just this B plus D over here. Now, in the case where we might value for its own sake a transfer of resources from one group to another, there's this weighting parameter W, which wasn't there before, because we were implicitly weighting all groups as being identical. But now, in this weighted cost benefit analysis version, we're going to actually just consider the benefits to this group of people, the benefits to these transfer recipients. We're going to consider them at some worth some scaled up proportion of the costs to other parties, in particular the producers and consumers in this goods market. So this parameter W represents the weight that's being applied to the recipients of this tax and transfer program. We can think about this as being, in the case that you might find this transfer program desirable, this W is going to be something greater than 1, indicating that these benefits actually count a little bit more than the benefits to the recipients of this transfer money count more than the losses to the consumers and producers in this goods market that lose as a result of this tax. So if you just conduct this cost benefit analysis now with this weighted version, now we have benefits equal to W times A plus C. We have costs equal to A plus B plus C plus D. So the net benefits to society, if we consider that new weighting scheme, are W minus 1 times the amount A plus C, which is the amount of the transfer that was occurring under that tax and transfer program. So A plus C again was the tax revenue. That's this blue rectangle. And now, whereas before in an unweighted cost benefit analysis, the transfer of those resources to somebody else actually had no net effect on society. Now the net effect is positive, given that we have this W greater than 1 to assign greater weight to these transfer recipients. And now, importantly, the value of this overall program is a function of this weight that's being chosen, right? And that's that makes it a little bit hard to in choosing an objective weight. Now the net present value of this project is basically what you decide it to be, because you can choose something that's greater than 1, and that may be desirable. It's just it's no longer out of your hands. It's like it's completely in your hands now, what you choose to be as your the value that you put on the benefits to those transfer recipients, and that in turn will dictate what the value of this project is. So just to summarize this, under a standard framework, the benefits of this tax and transfer program would be negative. Those would be considered a loss. This standard was essentially the unweighted CBA that I had just talked about. And then in contrast, now the net benefits of the weighted CBA are W minus 1, which is the extra proportion of weight that you put on the transfer recipients relative to everybody else, times the amount that they receive and the amount that's taken away from the consumers and producers in that good market. And then you still have the overall deadweight loss, but it could be, under this framework, it could be, depending on how large W is and depending on how large A plus B is relative to B plus D, now you could actually have something that comes out with net positive benefits because of that choice of weight, extra weight that you put on the transfer recipients, right? Okay, so that's the general idea. Now we had we had talked about, the reasons why we might want to do this, and I'll just go over those briefly again. So we have this implicit extra weight that we're putting on transfer recipients relative to to the producers and consumers in that goods market who are losing. It's somewhat arbitrary, and yet there's reasons for why it may be justified. I'll just go over those again. The reasons we might actually weight these benefits and costs to different parties is this idea of diminishing marginal benefits or diminishing marginal utility. Just the idea that extra income that's accruing to a low-income person increases the utility of a low-income person by more than an extra amount of income to a high-income person. And in that case, provided that that's true, you can, if you have kind of a utilitarian point of view where your goal is to sort of just maximize the sum of everybody's utility, get the most good for the most number of people, then a transfer from high-income individuals to low-income individuals would potentially accomplish that goal under this assumption that the utility or the benefits to low-income individuals of a certain amount of income are higher than what they are for the change in utility or the marginal benefits to a high-income person. This still requires, as I mentioned last week, this still requires making some kind of interpersonal comparisons. We can observe just internally for ourselves, and also just if we survey people, there's generally a consensus among individuals that they're the extra benefits they get from more income are really valuable to them at low levels of income, but then as they get richer, they feel those benefits a little bit less at the margin. But you're still stuck in this problem of not being able to really measure utility, because it's not a real thing. It's not an objective quantity that you can measure, like the mass of a proton or an electron. It's kind of a value laden concept, which is hard to make comparisons, therefore, between different people. So that's but nevertheless, that's one conceptual reason why it could be desirable to make these transfers. Now, independent of that reason, we mentioned last class a second reason, which is actually separate. It's distinct, even though it has similar. Even though it sounds a little bit similar, it's a little bit distinct. The second reason is that, from a social perspective, a more equal distribution of wealth in the society is preferable to a less equal distribution of wealth. And so the reasons we gave for that last class, just to reiterate, there's crime, or there's social disorder or social unrest that could result from having large gaps between the resources that different groups of people have access to. And so resources are destroyed, people are hurt in the process of this crime and disorder happening. And so that could potentially be reduced or minimized, or become less likely under a distribution of income in society that's a little bit more equal. You could also just think of the fact that there's well-off people in society who actually enjoy having people in the bottom of the distribution be lifted up, and that could give them inherent benefits just knowing that that's happening, and they could be more than happy to contribute to that, in which case having a program that transfers money to those individuals could help the well-off people insofar as they themselves actually benefit and get satisfaction from having that occur. And then the last potential reason for why a more equal distribution is preferable is that it makes it more likely that you have more people in society that are able to meet kind of a minimum threshold for having a dignified life. And there's sort of a threshold level for that. It's not like a continuous level where you know the degree to which you need a certain amount decreases. It's kind of you need to have a certain amount, and if you have less than that, then it's just really undesirable, both for the person and from a social perspective, to have people in society that are living that way, with not enough to meet their basic needs. And so this threshold reason could be a third distinct reason for having transfers of income. You can think of this as kind of insurance from a social perspective, kind of social insurance, whereby, you know, if individual insurance, you want to protect yourself against worst case outcomes. So you buy insurance against terrible things happening, you know, to your house or to your property. And so you buy insurance that would make you whole in the event that something terrible happens. From a social perspective, you can think of that as being, you know, we want to provide a safety net for people who are dealt a bad hand. We want to live in a society where even if you are dealt a bad hand, you're still able to meet your basic needs and live in a dignified way. And that could be just another reason for why such transfer programs, even though they might come out, you know, with negative net benefits, as we saw, if you're just using unweighted cost-benefit analysis, those could be desirable for that reason of just wanting to provide social insurance. So yeah, all of this implies that there's an increase in social welfare. I'm using SW to denote overall social welfare. The three reasons given above under number 2, the avoidance of crime, the utility that well-off people get from seeing a more equal distribution, and then the fact that there's a minimum threshold to live. Those all lead to a case potentially where the social welfare, I'm using SW to denote the social welfare, where that could actually be enhanced by more as a result of a low-income person increasing their income compared to a high-income person. And that's a social welfare, which is actually independent of whether or not the individual people themselves are experiencing directly higher utility from that money. You could think about if crime is reduced as a result of a more equal distribution, then there's in some sense more resources available overall for people to enjoy, less property destroyed, more people not getting injured as a result of that, and that's independent of actually people having income being transferred to them. It's sort of an extra effect of society overall being better off, having less destruction of property or less injuries as a result of a more equal distribution. Okay, so that was the second justification. The third justification is sort of a political philosophy justification, which gets at the idea that we want to just consider people's well-being and their changes in well-being that result from policies. We want to have some democracy in that. We want to have some democratization of people's either improvements in their well-being or reductions in their well-being. We want to sort of treat those amounts the same way. And so we kind of just describe that very simply with a simple example of high-income individuals with higher demand for a certain good because of their income. Low individuals with a lower quantity demanded at a given price because of their income is lower. You can think about this as maybe like a policy that would put a tax on energy or a tax on carbon and potentially increase the prices of energy that individuals are facing. This sort of policy, this something like a carbon tax, would have benefits from a social perspective, insofar as it reduces carbon dioxide emissions and mitigates future climate change damages. But the fact that those prices of energy would increase would have effects on both high income people as well as low income people. And you actually might register, if you have if you're using consumer surplus to register the gains and losses to different parties, you might register the losses to high income people as being higher than those to low income people, just merely because high income people would be consuming more energy anyway. And so the higher energy prices that they face are being translated into overall higher energy costs, more losses from their perspective, because they're using more energy anyway. And so you might register their loss from a carbon tax or something that increased the price of energy. You might register their loss as being greater than the loss to low income individuals. Whereas in reality, it may be the case that low income individuals, it actually affects them more in terms of their own well-being, because their energy prices are going up, and that's actually causing them to have to substitute away from certain other kinds of goods which have a high value to them. And so it may kind of get that process, or that it may get that evaluation backwards by assigning more weight to higher income individuals, whereas in reality there might be a higher burden overall, just kind of from an overall human perspective. It might be a higher burden on low income individuals. And so there's potentially under this one person, one vote philosophy. This sort of says that, in a democracy, everybody gets one vote, and it doesn't matter how much money you have. But in this economic context, this consumer surplus change is sort of counting to a higher degree for high income individuals and low income individuals. This sort of goes against this one person, one vote principle that we find equitable and just and fair and right in the political arena. And so this will be like the first example where we're thinking about, we're going to transition now from thinking about reasons for having transfers now to actually thinking about ways to actually practically implement this. And we introduced this last class, but I just want to go over this one more time. The idea here would be that you just adjust the consumer surplus. The consumer surplus changes, you adjust them according to what those consumer surplus changes would be if everybody had the same income. So you're going to make some scaling factor that you're going to apply to these changes in consumer surplus in order to satisfy. Basically, you're choosing some weights in order to satisfy this one person, one vote criteria. So the idea here is you'd make a policy evaluation. You'd consider, if this is a carbon tax, you'd be considering what are the overall changes in consumer surplus that low income households are facing. What are the changes in consumer surplus that high income houses are changing, or that high income houses are experiencing. You're sort of putting numbers on those. You're figuring those out with some knowledge about the demand for energy in these different groups of people based on their income. And then you're coming up with a set of weights here. So now we have, the consumer surplus for high income individuals or households. That was determined to be A plus B according to that conceptual diagram. The change in consumer surplus to low income individuals was found to be A. in that conceptual diagram. Now we might, if we're trying to satisfy this one person, one vote criteria, then we have this idea that we want these changes in consumer surplus to register as equal values for each group of people, not weighting one more heavily because they have higher income. And so one practical way of implementing this would be to implicitly look for some kind of weights, right? So what you're looking for, weights, WH, WL, weights that would be applied to these amounts of change in consumer surplus. And you want to figure out what those would be to satisfy this one person, one vote principle. So you don't necessarily need to know both of these numbers because what really only matters is their relative scale. So what one thing that allows you to do is just set one of them equal to 1. And so we did that here with setting the weight for the high income households equal to 1, and then solving for the weight on low income households that would make this one person, one vote criteria be satisfied. And so in this case, you have some losses to high income households, A plus B. You have some losses to low income households, A, according to the changes in consumer surplus that they experience, say under a carbon tax or under some policy that makes energy more expensive. And then you set WH equal to 1, solve for WL, and that would just be the ratio of change in consumer surplus to high income individuals, ratio of that to change in consumer surplus to low income individuals. And A plus B is larger than A, so this would implicitly be assigning a higher weight and a higher value to those low income households, merely as a result of the fact that their preferences are not registering as high because their income is lower, and therefore the economic calculation of consumer surplus is not giving them equal weight with the higher income households, right? So you'd have WH in this case equal to 1, WL equal to A plus B over A. Okay, that's one possible way of doing this to satisfy this one person, one vote criteria. Before we go on, I want to point out in general what we're doing here is the difference between standard cost benefit analysis and weighted cost benefit analysis is we're calculating NPV in a similar way as before. The only thing is now we have an extra parameter that we're using in the context of making these calculations. So I want to just point out what this general weighted CBA framework is before we move on to another kind of empirical method for figuring out what these weights could be. I want to just put this up here. J is the group index, and there are M groups because we're summing over each group, and we're doing it for all M groups. So it's actually M that represents the number of groups. So we have M groups, and again, we're in general we have flows of benefits and costs over time. So these benefits and costs over time are going to accrue to different people, starting at time 0 and going all the way up to time capital T, which is the terminal date of the project. We have in this case benefits and costs, but we're going to just add an extra subscript to these because we have group level benefits and costs. So now BTJ and CTJ are now the benefits and costs that accrue to group J at time T. So now we're just disaggregating this a little bit more, figuring out how these different benefits and costs accrue to different groups of people. These all get discounted according to the social discount rate S, according to when they occur. And now so far none of this is actually different than the unweighted cost benefit analysis. The only difference now is that we have this WJ, which is being multiplied against each of the individual benefit cost values that are accruing to each party or each group J. So so for each group J, you figure out what their what their benefits are, what their costs are. You figure out when those occur. You sum those up over time. You figure out the present value of those over time by using the discounting process, and then you multiply them by some WJ, some weighting factor, and that gives you the benefits, the net benefits, the benefits net of costs that accrue to group J. Multiplying that by WJ then scales those up or down according to how much you want to weight more or less heavily those benefits to that particular group. And then you do that for each group. So you do that for group 1, group 2, group 3. You do that for all M groups, and then you add those together, according to this outer summation, which represents the summation over each group, and that's the general form of this weighted cost benefit analysis. Right. So that's a general form of kind of what we were just doing above here, where we were taking the benefits and costs to this tax and transfer policy. In this case, we were assigning W equal to 1 for both the producers and consumers. Those are both getting a weight of 1, and so you'd have like disaggregated groups here: one for consumers, one for producers, one for the transfer recipients, and those transfer recipients would then have this W applied to this weighting factor applied to their receipts, and that would be something which once you would plug that into this general form, you have J equal to 1 could be the consumers, J equal to 2 could be the producers, and then J equal to 3 could be the transfer recipients. You would just apply each of those weights and then add those up, and that's sort of implicitly what's being done. If you were to take we had the W minus 1 times A plus B minus the B plus D, that would be already implicitly the expression that would be used for this the specific expression that would apply using this general framework. And I've actually combined these together. In reality, this would be W times A plus B, which is the net benefits to transfer recipients, plus the losses, plus the losses of A plus B to consumers, and then plus the losses B plus D to producers. These are consumers, these are producers, and these are recipients. And that would be the way that problem maps onto this general form of the NPV calculation. Okay, so that's the conceptually what's going on when we're doing weighted cost benefit analysis. The one more thing I want to try to tackle in this part, again, we're dealing with the question of how to determine the weights. And one way of doing this is to think about politically determined weights. And what I mean by that is what are the weights that politicians are implicitly choosing when they choose one policy over another, in the event that the policy they choose actually has a smaller net present value than the policy that they didn't choose, right? So that's kind of the abstract version of it. Let's try to think of this in the context of just a stylized case, as we usually do. It's helpful to think about stylized cases, I think, just to get the concept. So let's think about project. We have two projects, project 1, project 2. We have two groups, group A, group B. Each of these are going to have each of these groups individually are going to have some benefits associated with these projects, and so overall there's going to be some net benefit associated with these projects. We can think about project 1 having a net benefit to group A of 10. Project B, or project 2, project 1 having a net benefit to group B of 50. And therefore the net benefit of project 1, when you consider the payoffs to these different groups, the net benefit is 60. The units are important here. We're just thinking about relative amounts. Now, an alternative project, project 2, is going to pay off more for group A. It's going to give them double of what they would get under project 1. But group B is going to have smaller benefits under project 2 relative to project 1. And if we add these up, if we can think about these as the unweighted net benefits, then we have a net benefit of project 2 equal to 50. And so this project, if we're just going to be considering unweighted net present value, we have a net benefit of 60 for project 1, and so this would be the desirable project in the case that we're just doing an unweighted benefit cost analysis. Okay, now let's consider what happens when we have some policymaker we can actually observe them choosing project 2. So despite the fact that the unweighted cost-benefit analysis would yield a decision to choose project 1, let's say in actuality this project 2 is chosen. One of the things that this would let you do as someone that's maybe curious from an analytical perspective about which weights to choose, this observation that project 2 is chosen over project 1 actually gives you some information about how much the politicians or the bureaucrats, how much they are weighting the different benefits that are accruing to groups A and B. So if project 2 is chosen over project 1, there must have been some implicit weight that was placed on group A versus group B. And so we can actually analytically we can consider what those weights must have been in order for project 2 to be more desirable from a social or political perspective relative to project 1. So this we're going to have weights equal to WA in the event of that WA is the weight that's applied to group A's benefits. WB would be the weight that's applied to group B's benefits, right? So we sort of have two unknowns here. Now we have this thing here where the on its face, the net benefits of project 2 are only 50 relative to project 1's 60 net benefits. But we observe that politicians choose project 2. So we can adjust, we can actually adjust this number. We can adjust this number from 50 to something else. We know it's at least 60, right? We know that because we observed the politicians choosing project 2. We know that this project 2, under this implied weighting scheme, must have had at least net benefits of 60. Under whatever criteria they're using to weight these different groups. So we're adjusting that to 60. It could be more than 60, but we know that it's at least 60 because it was chosen over project 1, which it wouldn't have been if you were strictly just going by the net benefits. Okay. Now, this is a system of 2 equations and 2 unknowns. So we can actually just use some algebra here. The sum of the benefits to each of these groups being equal to this right-hand side number, which we know we adjusted this bottom one here to be equal to 60, because we know that under the implied weighting scheme, it must have at least been as much as project project 1. We could think about doing some algebra here, moving some of these terms around, solving for some of these things. If WA times 10 plus WB times 50 is 60, then WB times 50 is equal to 60 minus WA 10. So that's the first equation. We can take each of those and divide them by 50. So WB is going to be under this scheme. WB is going to be equal to 60 over 50 minus 10 over 50 WA. Right. So we solved the first one. Then if we substitute that expression, we know that WB is equal to 6/5 minus 1/5 times WA. We know that this quantity for WB can be plugged into here, and we can solve for WA. If you work that out, you can find that WB or WA is equal to 12/7, and WB is equal to 6/7. Right. So trusting that algebra, this method of observing that policy 2 was chosen over policy 1 tells you that it must be at least as good under a weighted cost-benefit analysis as policy 1. Policy 2 must be at least as good under a weighted cost-benefit analysis as policy 1. Therefore, the implied weights that must have been used in the process of making that decision, sort of the weights that make that second policy at least as good as the first policy, are given by this. Essentially, again, it's not so much important what the absolute numbers are, because anytime you're applying weighting measures to these, you're sort of you're fudging with the units anyway. But essentially, this is a scheme in which the ratio of benefits, or the ratio of the weights in project, or the ratio of the weights that are being applied to group A is at least 2 to 1. The weight that's being applied to group A is at least 2 times larger as group B. In the event that you observe politicians actually choosing this second policy over this first policy, they might be even using higher weights than 2 to 1. All we know is that it must have at least been 2 to 1, weighting the benefits to group A at least twice as much as group B. in order to get at the final decision of choosing project two, which had a lower net benefit under an unweighted cost benefit analysis. So this is a method of actually, it's an empirical method where you can, it's not necessarily up to you to choose these values, but you're able to observe. You know, it's a in that sense it's an observational weight. It's kind of a positive weighting. You're observing what's happening in the real world, and you're figuring out, okay, what must have the weights been in order to make one of those policies better than the other, despite having less net benefits under some sort of unweighted cost benefit analysis. So this is one way. We looked at the sort of the one person, one vote way, which sort of adjusts benefits in order to equalize the votes that are able to be expressed by each of those parties, making the values of their losses identical under sort of a democratic principle. This one is a little bit more agnostic about what should be done. It's simply looking at what is done and then determining what the process would have had to be for politicians to choose one of those policies which had lower unweighted net benefits. Okay, so that's just I think that's kind of an interesting. You know, you could do this with all sorts of policies. You could decide in evaluating environmental policy, you can observe, you know, policies that maybe have been enacted already in the last 20 or 30 years. Look at how those policies affected different groups, and sort of in a more complicated version of what I've just done here with this algebra. But in theory, you're able to then back out how the EPA or how a certain government agency must have been valuing those different benefits and costs which accrue to different groups. You can figure out how much the EPA must have been valuing those different groups in order to go forward with the policy they actually chose. So it's kind of an empirical basis for choosing weights. And under these weighting schemes, as we've seen kind of in that tax and transfer example, these are going to make transfers turn out to be potentially a net positive for society, whereas before they would be simply a zero change in a net zero change in social welfare. But under different choices of weights, these policies can come out, or you know, these policies can cause the results of the cost benefit analysis to be different, and you're sort of the results are in some sense up to the discretion of the researcher to choose a set of weights that they find desirable. But these are two examples: this one person, one vote method, as well as the backing out politically determined weights. Those are two ways of maybe putting some empirical basis on how you choose that stuff, and making it a little bit less arbitrary, and at least putting it in context. If nothing else, this method puts the method it puts the weighting scheme in context by relating it to something that has already been done in the past, which is at least anchors you to something that's real, and that's helpful to anchor yourself to something in the real world when you're trying to make some of these decisions. Practically, you know, when you're considering cost benefit analysis, I just have a couple practical comments. You know, do both a weighted and unweighted CBA. You know, it doesn't hurt to have more information, and you know, just simply including an extra parameter to scale up or down the benefits or costs that are accruing to different groups is the least of your difficulties in carrying out cost benefit analysis. You know, the most difficult things are the thorny evaluations of human life, and how to figure out how to discount the present versus the future. Those are sort of the difficult aspects of this. extremely difficult aspects of this. Um, Simply implementing, multiple versions of the same analysis is very easy to do. You have the computing resources to do it. It's not computationally difficult, and it's not analytically difficult to produce one version which maybe has which is one set of weights, and then a second version which has another, and then maybe one that's just unweighted, at least to allow you to see and maybe disaggregate the payoffs to different groups. Even if you're not weighting the different payoffs, having your benefit cost analysis be disaggregated according to who's winning and losing is a useful exercise and a useful and very informative way of presenting your results. And so that implies do sensitivity analysis, do break even analysis, look at which set of weights might be making one policy become positive net present value, switching from negative to positive. That's one way to do a break-even analysis. Choosing the weights that would make the policy switch from maybe a negative to a positive. That's one way to deal with this. Choosing different sets of weights. Those are all advisable when you're trying to come up with making these decisions that are inherently very subjective.